Can you hear it? All right. Well, this is our 4th Docker meeting. Definitely appreciate all of you guys coming out. I know we have some OpenStack people. Is that true? Anybody? Raise a hand. Okay. Couple guys. I know we invited the OpenStack group, so if you guys are here, thanks for coming out. Usually, right in the beginning, we pass the mic around. If anybody has a position they need filled, want to kind of give a shout out for anything, this is the time. Anybody? Just 2 architects and 2 system engineers. And what company? HP. All right.
All right. For StackEngine is looking for Go developers. So if
It was fantastic to work in. I'm jealous. So I work at Red Hat. I'm Michael. We're hiring all the time, all kinds of people. There are a few Red Hatters around, including this guy right here. There's one position close to my team that uses my project that I know about. It's essentially Python software engineer doing a lot of fun, really interesting kind of challenge. I know everybody says that, but it's really good stuff. So if anybody's looking for a Python job, come chat with me.
Once again, I'm Chris, and we actually have a position opening up for a Scrum Master PO for a DevOps team, in quotes, the DevOps team. If anybody is interested in that, just find me when the session's over, and we'll talk. So I lost Boyd, but Boyd is from StackEngine. He's going to start off, give about a 40 minute presentation, and then we decided to do a tell me what it is again. Lean coffee. Lean coffee. Cool. And just so you're not scared, if you've been to a FUDCon, Fedora conference, pretty much the same as when you get there. Just kind of throw up, hey, this is what I want to talk about. We'll narrow it down, and we'll just come up with some good discussions. So with that, I'm going to pass it over to Boyd, and let's go.
Thanks, Chris. Speaking of thanks, Chris, before we get started, I'm going to take a quick detour. So I'm the organizer of Austin DevOps. You can see we're fairly big and we get a lot of things done. On the 10th, we did lean beer. We figured that lean coffee wasn't appropriate past 7 o'clock, so we decided beer would be a better beverage choice. So when I say to you that the amount of effort that John and Chris go through to plan these things, get speakers, and most importantly, believe it or not, secure a venue, it's an enormous amount of work. So first of all, a round of applause for these guys. And secondly, a call to arms. All right, there's a lot of open source people in here. It's all community, community, community. This is your community, and you can make it better. All you have to do is reach out to those guys, all right? So whether that's I have a venue or whether it's I know a speaker or what have you, that's what makes things great. So, I mean, you know, for me, I got Jason Hand coming from VictorOps because somebody made an introduction. We've had Adrian Cockcroft from Netflix. We've had David Strauss from Pantheon. Want to talk containers? Talk to David Strauss. All right, so, you know, please take what you know and your reach into the community and make your community better by helping Chris and John out. Regularly scheduled program. I hate technology. That makes me a sysadmin, right? Oh, look, now that's not working either. Ha! What I get for putting it in my pocket, I guess. Okay, power path permissions, right? Power. Nope. All right, spacebar it is. All right, my name is Boyd Hemphill. I am part of StackEngine with Mike Rabb. I don't know where Mike went. There he is. We're going to tell you a bit about what StackEngine is doing in terms of Docker. But before we do that, what we have found is that we have mixed audiences. We have people who know way more about Docker than we ever did. You are a rock star. Thank you. It feels like home. Oh, what? My keynote just died. All right. And I'm not laughing with me, I'm laughing at me, so it's okay. Yeah. Surely I appreciate the effort. So I'm going to give this back to you so you don't lose your pieces. Thank you. All right, that just means you don't get to see me pace like a wild animal. All right, let's get this show on the road. Oh, you know, aha! I think that's called PEBCAC, yes? For those of you who don't know, PEBCAC problem exists between keyboard and chair. Yes, thank you. That was deja vu for those of you who want to learn French. Oh, man. All right. Ah! Thank you, people. I'm here all night. All right. Okay. Hello, and welcome to DockerRaleigh. All right, again, thanks to John and Chris. I'm Boyd Hemphill at BHempHigh. Mike is Mike Rabb, and he is at StackEngine, and we are all at StackEngine. All right, a little history about me. I was an Oracle developer first, then I went to PHP, so yes, I have seen all of the dark side. Then I was a system architect, then I was, yes, a DevOps director. Yeah, laugh, go ahead, and at me, not with me. That was really my title, the director of DevOps. And then now I'm an evangelist, and I'm not really sure which is sillier, the director of DevOps or evangelist. So you can decide, let me know later. All right, so I started Austin DevOps in 2012. We started talking about tools then. We started talking about philosophy, and we went from being about 100 people to being about 700 people, as you just saw a moment ago. All right, so I'm also one of the co-organizers of DevOps Days Austin, which is a hyper successful DevOps Days. 400 people come from around the country. Ernest Mueller actually runs that, and he's an amazing force of nature. This all is coming to a point. I became involved with Docker Austin in August. We want to build a community around Docker that's as vibrant as Austin DevOps. And the reason I bring that up is because I am talking to Docker right now about the first Docker Days. We'll do it in Austin. We're going to try and organize it as an unconference, as Chris described a moment ago. And so keep your eyes peeled for what's going on at StackEngine. And you might see that happen. Now, the reason I bring that up is if we can pull this off and we have a good model, we want to bring this to other places. There are a ton of people already sitting in this room. Raleigh looks to me like a place we would want to bring Docker Days Raleigh to if you guys are interested in doing that. So keep going on, keep watching there to see what's going on. All right, so a bit of history about StackEngine. Is anybody using CopperEgg? Okay, good. Yeah, they're having a little bit of trouble right now. But the founders of CopperEgg were bought by Idera, hung around for a little over a year, and now have decided, what's the next problem to solve? And they looked at Docker and they said, oh my God, you're going to have containers everywhere. We're going to need stuff to manage it, so we should do something for that. So they came up with the idea of StackEngine. Started in May of 2014 to address challenges facing Docker adopters. Okay, so we made our funding announcement in October. That's how John found us. We got $1 million in seed money. Seed is before A, so that means basically somebody handed our founders $1 million and said, go do something cool. You know, that's a nice problem to have. Currently, we are in private beta. So, you got to wait the velvet rope, and Mike Rabb back there is the guy who's standing there. He's kind of scary behind the velvet rope to let you in. So if you want to get into private beta, talk to Mike back there and he'll do it. All right, so now let me establish some common ground. When you want to talk to people you don't know, you have to talk about what you mean when you say a thing. So first of all, what's the goal of your company? Anybody? Bueller? Hell yeah. All right, and if you, how many of you have read the Phoenix Project? Okay, so since all the hands aren't up here, I'm going to take off my StackEngine hat for a moment. Put it right here. And I'm going to make you a personal plea. Read the Phoenix Project. Go out and buy it. You can get it for $10 on a Kindle or whatever. All right. If you read the Phoenix Project and you didn't like it, you add Hemphill me. I didn't like it. I will send you a check for $10. I will refund your money. If I happen to be in Raleigh or you happen to be in Austin, I'll buy you lunch. You just have to be willing to explain to me why you didn't like it. Now, don't go and tell me it's not a literary masterpiece and that Shakespeare would be embarrassed. I don't want to hear it. It's an allegory. What did you take away from it? Okay, I know that 50 pages into it, I was yelling at the book. It's not the sand. Find the idiot who's twiddling stuff when he shouldn't be. All right, so it's a novel, not a tech book. It's not continuous delivery. It's a novel about your life. Okay, so get excited about that. And it's also the seminal work on DevOps. So, oh, and by the way, it's based on the goal. So if you've already read the Phoenix Project, have you read the goal? I love you. And you too. All right, so read the goal. Okay, it's about a manufacturing plant. Cool thing for me, read the Phoenix Project, went, wow, that's cool. Since the goal was mentioned a bunch of times, I said, I went and read the goal. I don't know the first thing about manufacturing. Never even been on a manufacturing floor. But as I was reading the story, I was solving the problems with about 50% accuracy, just from reasoning from first principles. I thought that was pretty cool. So, there you go. If you're smarter than me, if you can do it better than 50%. So there's a challenge. Go. All right. So what is DevOps? Of course, DevOps has a brain with gears in it, right? All right, is it a process? Is it the intersection of overlapping concerns? That sounds so, is it a culture? That's a really fun one right now. No, actually, I believe that DevOps is a philosophy. And to make my point, first of all, I'll give you my definition of DevOps. It's the way in which a technology organization embeds itself in a business to the benefit of that business. That's what DevOps is. That's what DevOps is about. And that's how I reason when I talk about DevOps. Okay, now that picture. So we got brains with gears in them, and we got people having conversations with gears in it. Very DevOpsy, right? That picture is from Cambridge University's philosophy department. So when I say DevOps is a philosophy, I think I'm feeling pretty good about that. All right, so now let's get into some Docker. That's why we're here. All right, the ideal Docker application is service-oriented architecture. And of course, Netflix is the unicorn that everybody wants to talk about. They want to, change their rating engine, so they just bring up 700 new machines and they put the new code on there and they start moving traffic over, and then they're happy and they turn off the other 700 machines, and it's all, fluffy bunnies and rainbows, and that's really, really cool. So what are the benefits of this? Well, one of the biggest benefits with Docker is feature velocity. So you can accelerate a developer, because they can take risks, they can write code, they can try things, they can test faster, because they don't have to wait for a virtual machine to come up. Now, for those of you with a little bit of gray in your beard, do you remember when you would build your hand-built artisanal development environment on your laptop, and then you'd want to upgrade PHP, or you'd want to upgrade the JVM? Oh boy, that was dangerous, right? So a couple days later, when you finally got it right, you get back to developing. And then there was Vagrant, and now we get really aggravated when we have to wait 5 minutes for our Vagrant machine to come up. That's too long, right? So, man, the world has changed. And Docker's going to change that even more, because now you only have to wait, a couple of seconds for a container to spin up, and that means that developers can move faster. And if you want to think about that for just a minute, that means that there's more cash flow in your business. I'll make that connection in just a moment. Innovation velocity. So you want to upgrade the JVM? Go ahead, you can innovate. You want to try something out that was totally whack? Like you want to try rewriting something and go? You can do that. And you know what? It's disposable. If it didn't work, throw it away, try again, or throw away and go back to your mainline development. Density reduces costs. Okay, so that's the one that everybody talks about operationally. Wow, you can put more stuff on a server. Yeah, you can. And you know what? All of you guys sitting here waiting on, who are retailers, waiting on Black Friday, think about this. Right now, your web servers are sitting about 10%, and you're happy. I got 20 of those things. And if there's a spike before Black Friday because marketing did something cool they didn't tell us about, I love marketing, then, life is good, because the web server's got plenty of room. But if we achieve density, suddenly, well, we're dense. There's no more room. So you don't have that cushion anymore. That means operations has to think much, much more differently about how it's actually doing its capacity planning and its capacity reactions and its thinking. So, wow, sort of an unintended consequence, eh? Separation of concerns. So code to the interface. This was a big thing with extreme programming back in, was that 98? Was that when Fowler did extreme programming? Yeah, roughly 98. So, but code to an interface now with Docker, because you got a service and a service and a service, and they're all self-contained. That means that you can do that at the infrastructure level. You don't have to worry about coding to an interface. All you have to do is publish an interface, and your code could be the biggest rat's nest of spaghetti there ever was. How was that for a mixed metaphor? Rat's nest of spaghetti. All right, and you know what? It's okay, because as long as that API works, the other containers that are consuming it don't matter. Or, I'm sorry, don't care. They still work. So, taken together, if you can accelerate your developers, you define for your business a lasting competitive advantage. So if you go to StackEngine.com, what you'll see is a couple of blogs I wrote when I first got there. One argues that if you want to explain DevOps to somebody, you personally, you right there, yep, you should do a load of laundry a day instead of waiting until the weekend to do your laundry. Now, that sounds crazy, right? Okay. But if you think about it, that's the continuous integration model in a nutshell. All right, so do a load of laundry a day. All right, what's going to happen? Well, I'm not going to tell you. Go read the blog or try it. But what I will tell you is this. You're going to find that you don't have nearly as many clothes in the laundry, and you have a lot more clothes in your closet. So there's a couple of results. Go look in your closet. You see a lot of clothes, right? Picture that in your mind. Go look in your drawers. You see a lot of clothes in there. Now, think about all the price tags that were on those when they were new. That's all cash that's sitting in your closet, in your chest of drawers, that is not sending your kids to college, buying you a really cool car, a nice new gaming machine, whatever it is that you want, that money is sitting there. That's cash flow, folks. All right? So, excuse me. If you can accelerate your developers, they put more features into your source code repository. That source code repository is your closet. And if those new features are sitting in your closet, they're not making your company money. So what you've done is you've only achieved a local optima. You've only accelerated the developers. Those features can't get out of it because QA can't get to them fast enough. And even if QA could, well, let's take a look. This is still very early days for Docker. Okay, so when MySQL comes out with 5.6.32 or wherever they are now, nobody wants to have a meetup. When Docker comes out with 1.3.1, everybody's like, wow, what's new? This is awesome, right? It's early days. There are big changes coming. Some of those are breaking changes, and some of those are still unexpected. Tools to support, and by the way, operations hates that. Tools to support Dockerized applications are immature, or they simply don't exist yet. And service-oriented architecture is hard. Okay, so I understand service-oriented architecture and I can code, but I can't code service-oriented architecture very well. All right, so those developers are unicorns. Those are really awesome people. If you can find one, grab them, pay him a lot of money, do whatever he wants, or she. Increasing developer throughput is only the local optima. It's thus a false economy. If you go back and you read the goal, that point is made in there. And by the way, the guy who wrote the goal wasn't some business guy, he's a physicist. His name is Eliyahu Goldratt. All right, so concerns. Docker adoption is the first major DevOps initiative that's not really driven by ops. So what we've seen when we've been out to 60 some odd companies, 40 or so of which I've talked to, is that developers are driving the Docker adoption because it solves a problem for them in a better way than, say, Vagrant does. All right? So operators are going, well, wait a minute, DevOps is my thing. I'm the one that's the revolutionary here. So what we have is, well, the hallmark of DevOps has been best practices of developers being adopted, servers as code, checking all the things in, test-driven infrastructure. So we operators have looked at what developers do and say, we could do our jobs better if we did it that way. The Docker revolution, again, is the first mass initiative that harkens from the developers. And that means that there's a whole lot of social engineering that has to happen around people's egos and around developers who want to make something better, something more awesome, but they maybe don't have all the entire picture. They need to be educated. Their revolution should happen. Yes, yay, let's go. But we operators shouldn't be saying no. We should be saying, how can we help you understand what our concerns are so that we can work together, DevOps, to get over those? All right, so again, if you go and look up social engineering on Google, you get all this black hat stuff. It's really crazy. You know, it's all hacker this, and somebody's going to steal your personal information. That actually, so I actually went and did this. The definition of social engineering is simply using the principles of sociology to find a problem. I'm sorry, to find a solution to a problem that is between more than one person. All right. So let's talk a little bit about the software development lifecycle. Developers are moving forward, and in those shops, I'd say a little more than 50% of them, what we're seeing is QA isn't going no, QA is going, wait a minute, wow, I can have lots of containers and they're kind of like virtualization. That means I could model production better and I could test better. That means better quality, and this is really exciting. I need to figure this out. The other thing that people are really realizing is they can build giant test grids. I can do 7 versions of Ruby and every flavor and version of Linux back to 2003, and I can test it all. Woohoo! So if somebody wants to run PHP 4.9 on Red Hat 2, they can do that. Woohoo! I don't know why they would, but they could, and we can test it. All right, build engineers see parallelized build grids for faster feedback and better quality. And all of these things make developers faster because they close that feedback loop that we talk about so much. And then operations panics because there are no tools and there is no instrumentation. I love XKCD. One giggle. Oh man, you guys are a tough crowd. All right. So you're gonna laugh at me when I was having problems, but you know, you're not gonna laugh at XKCD? Oh my goodness. All right, all right, so the final mile. What is the final mile problem that I'm talking about? You have taken your containers, you're using them in development, the system is built, and images are produced. So we have these Docker images. They've been tested through the build system, everything is good. They're stored in our private Docker registry, or they're stored in Quay.io, or John Vincent Lucis mentioned to me last night? No, 2 nights ago. Sorry. He mentioned to me 2 nights ago that Artifactory is now capable of handling Docker images, which is pretty exciting if you're using Java or something else where you've got a lot of build artifacts that you need to manage. So, but now we need to deploy to the QA environment to get the testing done. So we build a manual solution, right? That's going to work out really well. Don't let go. Oh, hey, by the way, you should be doing this too. Wish you would have told me. And so here comes StackEngine. We think we have a better way. We're trying to bridge this gap with tools, with a tool, in fact, instead of multiple tools. And so what our tool looks like, if you want to get your container from your private registry to production, is like this. You create a component that represents your registry. Basically, that's your connection string and the URI for the registry. Excuse me. You fill in your information. Then you create a component, you create a component that describes the image that you want to run and the container that it will be. You tell it what hosts in the mesh that you want to run on. And we've tested ourselves up to 912 hosts, each with about 30 containers on them, before we tipped over. So we can handle a bit of load. We haven't really found anybody who's pushing the limits for reals in production like that yet. Most of the production instances we're seeing are no bigger than 20 hosts. So then you wait for a second. Magic happens. Those are called remote procedure calls, by the way. I've always thought of them as magic. And life is good. We have all those containers. Now, since that was a BusyBox example, of course, BusyBox comes up, and you can see, is this actually, nope, darn. All right. You can see in the command column, it was bin sh, and since I wasn't running it interactively, BusyBox started, and then it stopped right away. So if I was to push the start button on one of those containers, BusyBox would come up and stop again. I could remove the container just by hitting the remove button. That's going to erase it from the world, right? So that would be the equivalent of DockerRaleigh and then the container name. So StackEngine is developing a tool to make this all policy-based. And once we've done that, we get fluffy bunnies and rainbows. Because containers, we're really talking about, well, people say cattle, not pets. But really, we've been talking about cattle, not pets since the configuration management revolution. Really, now we're not talking about cattle, we're talking about ants. Cattle, you still try to enumerate. you still tag them and stuff like that. Ants, you don't care. As long as you have a lot of them, whatever they're doing is fine. Okay, so, and if you kill one, oh, that's all right. You know you're going to get a bunch more here in a minute, right? And that's what policy-based is. If one of those containers dies, StackEngine's mesh is going to go, oh, look, that container died. I'm going to try and start it again. And if that doesn't work out really well, it's going to email you. It's going to alert you. It's going to send a message to HipChat. It's going to do something to tell you, hey, something happened. One of your ants died, and we tried to make it better, but it didn't work out. You need to intervene now. Because you're going to have so many of those things, you can't watch them all. All right, so the next problem that we're running into, or at least that we perceive is going to happen in production, is container sprawl. So first there was VMware, and suddenly large corporations departments could easily spin up environments. So you'd have some developer who had a really great idea, and he'd go and he'd say, hey, could you give me a VM? And they'd say, here you go. And he'd try that out, and innovation happened a lot faster, and that was really cool. And then he'd leave that VM on, and he'd go back to his mainline programming, and then he'd do it again. And another developer would have a great idea. And suddenly you have all these virtual machines out there. And you know what? Operators never get fired for for leaving something on. They will certainly get fired for turning something off. So you have all these virtual machines out there. Nobody knows what they are. Nobody knows what they do. And oh my goodness, I can't turn any of them off. I'm frozen. And I'm paying that VMware license. Ouch. All right, so that happened. And then there was the cloud. And this is where it really gets sticky, because with the cloud, all you need is a credit card. And developers have those, and we pay them well. And so they're like, oh, hey, look, there's a free tier. I want to go try this thing out. And so they do, and they have this really, really cool idea. They're innovating. We want this. And they show a business person, look at this cool data thing I did. Do you think this is valuable? And they go, hells yeah, thank you so much. And then they show their friend next to them, and their friend next to them. And suddenly this entire department depends on this thing that's running on an EC2 Teeny. T1 Micro, excuse me. Yeah, those were great, weren't they? Yeah, production all the way. So it's running on this T1 Micro. And they're saying, oh, look, it's tipping over. Too many people are using it, or it's gotten really slow. What's the deal? And so they go to the operations team, and the operations team says, we don't know what that is. Oh, it's in this cloud thing, right? So now we have stuff sprawling all over the place. So we went from 20 hosts in a rack to 400 hosts on that rack as virtual machines as we achieved a better density. And now we're talking about 4,000 or 40,000 containers. And if your problem is bigger than that, of course, you can do the orders of magnitude, the O's of n yourself, okay? So, and now there's Docker, and developers are creating numerous abstractions that are not managed like traditional VMs, okay? There are plenty of developers who are just taking the Rails application and stuffing it into a container with run it or supervisor D, right? But we know that those folks are just trying out the new and latest thing. There is another class of developer who's going, okay, if I have a Rails app, I need my web server here, and that's going to go in a container. And I need my Rails engine here, and that's going to go in a container. I need my own application code here that's running in gUnicorn or something other that's fancy. That goes here. I need a database. Are we going to put databases in a container? Why would you? Databases want to use the entire machine, right? They're designed to do that. So if you've got a database running on a virtual machine inside of a container, you've made your database maybe not as awesome as it could be. So, but we still need to treat that database as a service, which we can do through connection strings and stuff like that. RDS is a great example, right? So we need to think about that, because otherwise we're going to end up like the DevOps movement. Now remember, I love the DevOps movement, right? Okay, hey, we need to roll back a change to a relational database. Oh, but look over here, DevOps, right? There's an awful lot of hand waving that goes around when you start trying to manage data in terms of releases, rollbacks, and things of that nature. So containers on VM, on physical hardware, located in availability zones, in data centers, on geographic regions. We're already describing the bin packing problem. We haven't even mentioned load or memory yet, right? So these bins are going to be 11 space, 12 space. We're talking about string theory here, people. So this is not a trivial problem, all right? During the hack day, didn't they? So yeah, so they mentioned it too. They're thinking about it. It's hard. And again, our heads hurt. So remember that one of the problems that operators are going to face is as developers break up their stuff into containers, and we want to run those containers, and we need to know what those containers are doing, we're going to have to manage all that. So StackEngine is working to make this, again, policy-based. So you don't need to know where it is. All you need to do is say, I have 7 containers of this kind. I want them to be in 3 different data zones, I'm sorry, in 3 different data centers, and I want them there to be at least 2 of them in any given data center. Okay, great. We'll go and do that for you, and you just sit back and, you know, get another cup of coffee and actually think about the next big problem that's going to make your company money rather than trying to click the on button to make sure something's working or servicing that last alert. All right, the next thing we're doing right now is inventory management. Okay, once you have all these things right now, how do I know that where they are and what they're doing? Because let's face it, we could have the policy stuff all going right now, but you're still going to want to drill down and see that thing to make sure it's working, right? Trust but verify. So you need to have a way to do the verify. All right, so where's my stuff? This is a picture of the host screen. Those are the hosts that we have up right now in that demo that you saw me trying to pull back together. And you can see that right now we're telling you what % memory is used, what % CPU is used, what the Docker version is, stuff like that. And one of our customers pointed out to us the other day, % memory is stupid. What were you thinking? Well, of course they were right. Because if you want to schedule another container onto a machine, knowing that 12% of memory has been used is useless. You need to know exactly, absolutely how much memory has been used so that you know that I can take this container that the developer has told me needs 1 GB of memory and put it somewhere where there is 1 GB of memory, not 10% of memory, right? So yeah, relative measures, while easy for us to grab, are, well, not so useful. So we need to fix that. Okay. Where's your stuff? Your images. You want to know where your images are, because if your image is already on a machine, you're going to be able to start a container really, really fast. If your image is not on a machine and it's really, really big, you're going to end up starting that container really, really slow, depending on where it is and what your network configuration is like, or network performance, I should say. We'll also show you where your containers are. We looked at the screen a little bit ago. So these containers, you can see which hosts they're on. You can click into them to get some details. I'll show you that in just a second. You can see what they're running and so forth and so on. So geographically, we're also working on, we don't have this yet, what location you're in. So since we love all the shipping container things, I went and I found all of the shipyards in the world. Wow, awesome, cool. So imagine that we need to know that we have things in Australia, what they're doing, et cetera, et cetera. Telemetry. What does monitoring a Docker app look like? Well, one of the things we learned from that host screen when I saw that % memory was 50% for one container, and I'm sorry, 50%. Pardon me. I had a 900 megabyte container that was running a Go binary. That's all I was doing, was running the Go binary. It was 900 megabytes. Because of the way I built it, it was stupid. I actually compiled the Go binary in the container. Not the brightest idea I ever had, but I was learning. So then I learned about this BusyBox thing. I thought, cool. And that 900 megabyte container turned into an 18 megabyte container. That's pretty awesome when you think about portability and stuff like that. So I got really excited. Then I started them both on the same host. And I noticed that the hosts that had the smaller containers on them were using half as much CPU and half as much memory as the hosts with the larger containers on them. And I thought, that doesn't make any sense. Or at least, it's the same binary. Well, I started digging. And so what I ended up doing is I got all the way down into sysctl and found all the metrics and stuff like that. And while I still can't explain why, I can tell you it is actually what's going on with the containers. So if you want to read about what I did, how I did it, and what I drilled down to, and you know why that happened, please write that in the comments of the blog, because the folks at Docker haven't answered me yet. What does log aggregation look like? So we are not a SaaS company. We are going to sell you installed software. We don't want to aggregate your logs. Splunk failed at aggregating logs in a SaaS fashion. Now, I mean, Splunk is the end-all be-all of log aggregation and surfing and all that. And then you have really great solutions out there like Sumo Logic and Loggly and Papertrail. But it turns out that Jeff Lindsay wrote this little thing called Logspout. And drop Logspout onto your machine, your host, when you bring it up as the first container, point it at your syslog, and then spin up new containers, and everything goes to, every container that comes up is now piped to syslog. Now run syslog out to Papertrail, and you have this blog that shows you how to do that in about an hour. So if you want to POC that, if you want to see what you could do with logging and do some searching of your logs, you can get that done, like I said, in about an hour. All right, and again, I actually evaluate their Papertrail and Sumo Logic and all that for the purpose, and explain why I chose the things that I did. That way, if you have different requirements, you can reason against my reasoning. So it's a longer blog that you can skip to the end to just get to the meat of this is how to do it. All right, so what is your stuff not doing? Well, first of all, do I have all the things that I think I should have? In this case, you can see this is our dashboard, and you see the big fat 0 with locations. That's what I was mentioning earlier with the map. We need to make sure we have no more 0. What's my stuff doing? So this is a host. Okay, this is the details of a host. So when you drill down to a host, you can say, that's how it's performing up in the upper left. And those are all the containers on it. So now I have this host. I can drill down the container. And finally, I can look at exactly what the container is doing, all the way down the container level. I can even control the container in the upper left. That one's paused. I can start it. I can stop it. Do whatever with it. The bottom left is expanders. So if you want to see what all the environment variables are, you can do all those things as well. So we need more telemetry. It's not good enough to just say what's CPU being used, what's the memory being used. We need to figure out what those things are so we can actually define the dimensions of the bin, find the dimensions of the objects that we're trying to place in the bins, and then do that intelligently for you in that policy-based method that we're talking about. Finally, we're looking at components. So we've decided that we want to abstract things like Amazon, private Docker registries, DigitalOcean, you name it, and probably the services within those as well. RDS, Rackspace's cloud database, if you want a competitor, that sort of thing. So we need to look at those things. We need to be able to define that component so that you can interact with it. We saw an example of that when we set up the private Docker registry as from Quay earlier. Components can be arranged in logical ways to represent your physical infrastructure, okay? So I'll go through a quick, very ghetto example. I did not sew these containers together. I don't want you to get the idea that I did that, because there's a whole lot of stuff that, a whole lot of assumptions you have to make about port mappings and what the application is doing. However, so what I can do is I have that bhempi Quay, so I went and got that. And then I set up a bunch of private, if you will, images or components, Nginx, PHP, FPM, Redis, MySQL, and I'm not sure what that job server thing is. And I'm going to go and I'm going to build a simple LAMP stack. All right. So the first thing I'm going to do is I'm going to run my MySQL container. Yes, I know that's oxymoronic. I sort of argued against that. It's an example. Okay, then I'm going to go and I'm going to start 3 web servers. And those 3 web servers ostensibly will, when they start, know how to find through service discovery, pardon me, the database server. Then I'm going to start my application server, in this case PHP FPM. It's going to know where to find its reverse proxy, those Nginx servers. It's also going to know where to find its database server. And then I'm going to start up a couple cache servers on a couple of different places. I'm going to make sure that those stay at 512 megabytes so they don't take up the entire machine. And I'm sorry, and voila, right? So if I've got all of the applications set up to talk across the network, and I can do the container, the networking on the container by setting up the ports and the environment variables necessary to do that in sort of a 12-factor kind of way, then life is good. So that covers what we can do now. Big research that I've been doing lately in terms of informing the engineering team. I'm not one of the engineering team. I guess I'm operations and the mouth of StackEngine. So, service discovery is what we've been looking at. So to do that, if you're not sure, you're not sure what service discovery is, it's really like a game of Go Fish. I have a service that starts. It needs to find other services. For instance, I have PHP start, and it needs to find the database. So it goes to this thing called a service registry or a service discovery tool, and it says, give me all your database. And the service discovery says, here they are. And it says, oh, I need that one, because it knows what tag it needs. For instance, maybe you have a number of databases, one for each customer. All right. So it pulls that back. It doesn't know the IP. It doesn't know the port it's running on, none of those things. So when it gets that back, it goes, oh, and this is the connection string. Poof, connects to it, life goes on. There are 3 essential ways that that's being accomplished right now. With Zookeeper, which is an Apache project, you have a persistent network connection. So if you're in a cloud, you can't depend on the network being awesome. So what the problem with Zookeeper is that persistent network connection, which is really awesome if you're stable. When you get network perturbations, Zookeeper starts thinking that half your application is missing and shuts off 2 data centers worth of stuff sometimes. So it can be really difficult to use in that sense. But if you really need that high availability so that the instant that something goes away, your application is aware of it, Zookeeper is probably the right choice for you. Then a step down from that, if you want to think of Zookeeper as sort of ACID compliance, if you want to make sort of a database comparison, you have etcd and you have console. These work on the Raft protocol, and so you have more of an eventual consistency. Your application is going to have to check back every so often. All right, so what we learned is that etcd is really great, but it still has the scaling problems in the way they implemented the Raft protocol. And console is really the best mousetrap out there in our opinion, because one, it has a DNS interface, which is really great. Most applications already know how to talk DNS on some level, so console has that already built in, and then it has the health checks. And those are really, in my mind, the killer feature. Because what console does is it for you will go out and check the health of your service. And if you're clever, you can use something like Sensu, stick it on the machine, and have it start pushing information to console as well. And if anything goes wrong, console will say, the next time somebody checks in for a service, console will say, that one's not available. So basically what that means is if a container dies, console's not going to point people at that dead container. And when the new container comes up, console's going to point people at that new container as long as it's healthy. All right, so we feel that console is the best mousetrap, and that was the one that we were going to base our service discovery on as we tackled that problem. What I think is interesting is while service discovery is really kind of a new and cool thing, really a very basic version of service discovery is already being used by people who use Chef, especially when they use it with a Chef server, and Puppet with Hiera. Okay, when I want to bring up a LAMP application, I start the database. And then when I start my web servers that have PHP on them, Chef goes and says, where do I have the database for this customer? Now the problem here is it'll find it. It has a beautiful search interface, right? But what won't happen is if that database goes away or something about it changes, like occasionally at Amazon, your IP will change, right? So what will happen is the Chef server is unaware of that. And so every time a new, like if you need to put up a new web server or you're doing a release and you do that A/B with your web servers, you're going to get the wrong database or you're going to get a dead database. So while those things are great for finding things on start, they're not great for running your application over time. So service discovery, it allows multiple deployments of the same service on a host as well, because we don't want to have to manage the ports of MySQL to MySQL containers on a single host. I use MySQL, by the way, because I was a MySQL DBA. So the first one comes up, of course, it's going to be on 3306. The second one comes up, it can't be on 3306. I don't want to specify, I don't want rules or anything like that. It needs to be on 3305. I just want to come up on any port, I don't care. And I want the thing that's looking for that one to check with service discovery to find it, not with me. I'm busy. I'm doing something else. I'm providing value to the company, not managing a bunch of ports. Containers register themselves upon startup and are found by tags, again, rather than URIs, fixed ports, etc. We favor something like console with a search interface for the Chef server. So again, we like console, but like the Chef server and Hiera both have this beautiful search interface. It looks like Lucene. In fact, it is under the covers. And we want that. We want that for us if we can pull it off. Now we don't want to implement Lucene because that means a JVM and we're writing our stuff in Go. So we'll have to see what we can do. All right, and finally, this again is a step towards cattle, not pets, and really ants. So a higher level version of our roadmap, like I said, I went crazy with meme generator. So service discovery. Of course, that's the one, like I said, we put the R&D time into in terms of how we want the product to look. And then there's user management. Right now, our customers are saying, we don't need to have ACLs and all that other stuff. Just give us a username and a password. We want to try this thing out. We're still getting our feet underneath us in production. So the addition of components, we need to add AWS, we need to add VMware, we need to add DigitalOcean. We need to figure out what level, if AWS is enough, we just get your keys and magic happens, or if we need to talk about services that are offered within AWS, SQS, RDS, and so forth. We need better telemetry, as I was mentioning. We need to make sure we're using absolute measures. We need more of them. We need load. IO weight would be great, steal. And of course, there's scheduling, right? The big bin packing problem. And finally, A/B deployment, which is also known as Phoenix deployment, which I think is really funny because doesn't the Phoenix have to burn before it comes back? Isn't that sort of backwards from what you really want to do? So And now, Al Gore and his gremlins willing, Daniel Day-Lewis or Mike Robb will give us an actual live demo, so you can see that it's not just PowerPoint, and you can actually go and install this thing.
Mike from StackEngine. Raleigh.
Mike from StackEngine. Great to be here in Raleigh. Let's see here. Thank you. All right, Boyd. Where'd you put it?
Mike is Mac.
On now. So you think the engineer still left it there? This will prove it. I can click on this. Ah. So we're so Boyd and I get here this set up, and we get on the Wi-Fi. I'm like, did you fire up some servers so we can demo tonight? Oh yeah, it's been running since we started this whole gig in Atlanta on Tuesday night at the DevOps meetup, and then we had Atlanta Docker meetup last night, and the whole demo's been running, right? And it's just been running. Because we put stuff in there, and it's just ethereal. I mean, it's a few Amazon instances that we have it running on, but our binary is running it. And so tonight we walk in here, we get on the Wi-Fi. I don't know what happened, but I think what's going on is some of our engineers are doing load testing. So it was just scaling whole bunches of hosts, and we're just part of the fray. So they bring us down, and we're like, no, I don't know, what do we have? 70 people here? We're going to show a demo tonight. You got to keep our stuff. You leave these hosts alone. So anyway, StackEngine is a binary that's installed on a server, host, virtual machine, EC2 server, all that flavor. On Linux, could be on RHEL, could be on CentOS, could be on Ubuntu, okay, CoreOS, all those types of things. We run alongside the Docker daemon. So we run right alongside of it. So you could even pre-install us on host. And if you are rolling containers, by the way, how many people in here even have touched Docker or done anything with it? Okay, Docker. There you go. So you know what a container is, right? It's the manifestation of an image when it's running on a host. Okay, so it's that that magic that Linux gives you. So if we're already running on a host, if there's no containers running on it, we'll still run and we'll still show you information about that host. So when I go down here, right now, if you look here, I've got 8 running hosts, or 8 running hosts of 8 total. So if some of them were not running, you'd see that. But if I go down to the host screens, I see my list of hosts. I can sort this by memory used, and Boyd made the good point that we basically need to make this absolute. So if I need 2 gigs of space because I need to run a 2 gig container, and maybe I need 2 gigs of buffer on that, I can find it easily. But you can see the hosts, and the beauty is even without any containers running, if I drill down on a host, I can still see the health of the host through StackEngine. Now, we also, since we're running right next to the Docker daemon on the host, will show you any images that are sitting on that host. So if I've got an inventory of all my images. Now, I will be honest, this is beta 1. We put this out about 2 weeks ago. Cool thing is, customers that we're working with, and I'm working with about 65 different customers who, and you know how it is, people get busy, so it's kind of cycles in and out as people give feedback. But one of the things they wanted to do was see the diffs on the images. So they wanted to see kind of the history of the layers of the images that we got. So we are moving to beta 2, and we got this holiday next week. We're trying to develop something and get to market. So they put this holiday in the middle, but we're going to try to get it out next week, if not right after Thanksgiving. So we are enhancing what we have here with image, more information around images, like I say, with the diffs and that type of thing. But like I say, if we're sitting on the host, you see that. You see all the containers running on a host. I can go here. If I scroll down, again, all the different dispositions. If I wanted to stop a container, right, I do not have to know the command line, Docker command line, to stop that container that I just stopped, right? I can stop, I can pause, I can start, And for you developers out there that spin up a whole bunch of containers and then go, oh, I got to go take them all down, I can go remove them. In beta 2, we're enhancing this with a multi-select. You know, a little box on the left-hand side there. You click the top one, they all light up. And I go, okay, I'm going to remove all these guys. StackEngine will take care of that for you. But I think the coolest feature, and I did a video on this, it's out on YouTube, is if you come down here into components, the coolest thing about components is let's say I approve an image, and that's the image that I want for my Redis server. Okay, it has everything I need, all my configuration, blah, blah, blah. I have an image. I create that as a component, right? So if I want to create a new Docker component, it's just as easily as filling in some information, and I create that. Once that's created, any of these guys, I can just click it, run, right? If I want to run this, I just give it a name. I'm just going to put something really simple, EEE, because I've got to hold the microphone in the other hand. I'm going to run 4 of those, and I'm going to put them across. Now, this is really cool. I have heard that not every, even open source software out there, can launch across multiple hosts at one time. So we're going to take this image that's a component, and we're going to launch that here into production just as easily as this. Okay, so right now, StackEngine is going out, grabbing that image, instantiating that image as a container on the host that I selected. And this host could be anywhere. Now this is running in AWS. It could be anywhere, could be on VMware, could be any of that. So this concept of components, and this is not exposed within our product yet, they're the building blocks, the models that will allow us to do the orchestration. So I want to take these components and I want to launch them if I need to scale on these hosts that are in Amazon. And if we have your Amazon credentials, we'll spin up those hosts for you. Put our, and then you build us into the AMI, we're there, everything is right with the world. So that's spinning up now, and I hope I didn't, Boyd's not here, I probably picked a big image that I'm spinning up. But that's going to go, and I'm sure it's a demo, I'm sure it's going to work. I hear laughter. Yeah. Anyway, we're going to give that a sec here, and it should finish up. In the meantime, what I want to do is, that's pretty much what I wanted to show you tonight. So where we are, we're a commercial company, okay? This isn't open source. Go back to the first rule. I'm an American. I want to make money. We want to sell software that makes money. We are in beta right now. I'm finishing the wave of beta 1. Like I say, we'll go to beta 2 by the end of the month. If anybody in here is interested in participating, email me, Mike, M-I-K-E, at stackengine.com. It's real easy. I'll get back to you. I interface with you. So, okay, what flavor of Linux are you guys running? Great. How big? I kind of want to. I build a matrix of kind of where we're being run and what's working, what's not working. What is our feed that back into engineering? What does our test matrix need to be? Because that's where people are running. All of that kind of stuff. So if you are interested, like I say, beta 2's got a ton of enhancements. Some, I don't know, might run better than that. I bet you it will. Just see me, and we'll go from there. Any questions at all? Yes, sir. Uh-huh. Yes. Right. Yeah.
What
Well,
turns me on is Docker.
so
That's what you gotta do.
well, that's exactly what we're building. We're building a Docker management system for the masses. Okay, and people are going to be operations people that need to know how to run this stuff in operations. We're producing a tool to allow them to take it and run it and take it out of development and do that. So that's exactly one of our design principles.
You have the information. Know about these and I said, number of different outfits.
Well, the,
Our first customer is in Texas Tech. Customer is Tech. Academics with PhDs. Well,
Yeah,
you
well.
keep referring to yourself as an academic. Understand academics. Thing is, doing is has already shown value. Explanation, your postulation around if you could just start a bunch of containers on a host is a genesis. It's a genesis. So that we do right,
Well,
but okay, I'd like to finish my sentence. So it's a genesis argument. Yeah, you can start all those things. Actually, that's really easy to do. You could script it. You could use Python Fabric and you're done. So managing those things after they're up, that's the hard thing. So that's the difficult problem to solve, and that's the actual value that we're trying to bring to the market. That else goes aside.
Right.
Docker is a lot because
Right.
all
Well,
I'm saying there.
okay. Appreciate that. I think that's a good and valid question. The customers that we're talking to, Fortune 50 companies, a lot of times they want to manage containers across. One of them said a dozen clouds. AWS is one of them, and so I think there'll be the concept of managing ever how we do it with AWS. Today, it's fire up an EC2 server and dump a container on it, which is very easy, by the way. So there could be deeper integration there. There's going to be integration with Joyent, so there's going to be other pieces to this. VMware is very important. The team was in California today meeting with them. So I think that the Docker's biggest promise is portability across clouds, public, private, and we want to support that. Yeah, so we haven't arrived at our pricing model yet. There probably will be parts. Yeah, but this is still early days, and there's a lot of road to go travel here. So we're just looking for people to come with us on that. Yes, sir. Back here. Right. I wouldn't say it's competing. I would say that, again, go back to the ability to give the masses operational control across clouds. So if stuff's based on Cloud Foundry, great. If it's based on OpenStack, great. If it's based on whatever, we want to be able to help people move and manage that, and we're talking large production environments. Right. So that could be more competitive. Yeah. I'm sorry. He said, how do we compare to Panamax? And yeah, there will be competitors out there. I'm not saying we will be the end all in this space. We'll compete on our merits. Right.
It's like no SQL. Look, CouchDB and everything else is stupid. Turns out that no SQL really meant not only SQL. Got a whole lot better really fast.
Yes, sir. So our customers are asking us to run. They want to take the binary and put it where they want. If it's behind a firewall, if it's on a private cloud, they want to do that. So our licensing model will, there'll be a SaaS-based licensing piece. But if you need to take your license file and install it locally, we'll support that as well. You'll install it on your own host. So the only thing that's going to be SaaS-based is your account management and licensing. Haven't had any demand for it right now. We could do that. Basically, we would, the way it works is there's some leaders that you set up and some followers in a mesh, and we could host that for folks. But right now, it's so simple. Nobody's asked us for it yet. Yes, sir. Okay, sorry. He asked, are we SaaS or on-prem? And right now, people are using us in an on-prem. When I say on-prem, I mean they're taking our binary. You do not have to use. There's no SaaS StackEngine right now. Yes.
So one thing
Right. It is. All those guys are first-class objects. And again, models, which is not exposed in the UI, will make those dance. And set it and forget it kind of thing.
I should also
Mm-hmm.
happening in the UI.
Yeah, nothing's hardwired on the UI side. APIs there today. It's REST. It's all REST based. I say the API is there today, and it's all REST based. Right. This guy's been on stage before. All right. Anything else? Ken, yeah.
I'll repeat you. So, what was your name? Mohammed's asked, how have we given any thought yet to how StackEngine will be upgraded?
So you have version 1, and now you want to install version 1.1. What will that look like? So that's our, wow, you want a job? So yes, we have actually given a lot of thought to it. So to answer your question, yes. Have we acted upon that thought? No. Why? Well, okay, you're chortling like you know why. Well, okay, that's really fair, right? If you follow the methodology of the Lean Startup, another great book to read if you're in the startup world, then it says don't do it until you have to. So we're not. But ultimately, so in doing the console research, another one of the things I was looking at is how do you upgrade Zookeeper? The answer is run away. How do you upgrade etcd? And if you're running CoreOS, that is so slick, it makes me want to cry. And I really, really want that for us. Okay, but CoreOS has this really killer little feature. I think if you go to, is it now.coreos.io or /now or something like that, you get a hash, right? And you get a unique hash. And that is your unique hash. It's sort of like having a global service discovery. And so you can use that. So we want to kind of combine that with, if you go and you look at console's documentation on how to upgrade. So we're trying to figure out how to munge those two things together to get a really smooth upgrade path. So we are thinking about that, but when you want to upgrade a distributed application, if you think about, all right, I upgrade my leader, okay, but it was down, so is it still the leader? And do I care? And you say it becomes really, really difficult when it's a distributed application. So yes, we are thinking about it, we haven't acted yet. So what Mohammed is saying is if I'm going to pay, one of the things I want to pay for is a really smooth upgrade path. It's a great point. Thank you. Other questions? Comments? Really? All right. Well, thank you very much for your time and your interest. And